2D? Love to. So questions from the homework last day? 2D. I'm going to break these up into two separate ones. Now this is, on the top, 25 times 24 times 23 times 22 times 21. Did you hear me say 21? You know what? This is 25 times 24 times 23 times 22 times 21 factorial, because it really goes 21, 20, 19, 18, and I can replace the 21, 20, 19, 18 with a 21 factorial. Is that okay? So this is the 21, 20 would cancel out with that 21, 20, 19, 18. Is that okay? Here, which one's bigger, the top or the bottom one? 11 factorial is 11 times 10 times 9 times 8 times 7 times 6 times 5 times. You know what? It's 10 times 9 times 8 times 7 factorial. This is 11 times 10 times 9 times 8. Now I'll go to my calculator, I think. Although I could probably try doing a bit more canceling. There's a, it's that times that. Okay. I'm not going to give you one like this to simplify. I don't mind doing this with numbers. I'm telling you on your test, Cassandra, you're going to get something like number 3 to simplify. You're going to get an algebraic factorial. Any others? 3a, did you try it? Okay. What's bigger, n factorial or n? Now, so I'm going to start to expand it. N factorial is n, yes, times n minus 1 times n minus, you know what? It's n times n minus 1 factorial. Can the n's cancel? Is it factored? Yeah, I keep saying the word factorial. It is factored. This one is a bit strange because there wasn't a factorial in the bottom, but as it turns out, n factorial divided by n is n minus 1 factorial. Or if I want to put it in numbers, 10 factorial divided by 10. The top is 10 times 9 times 8 times 7. The 10s would cancel. You'd have a 9, 8, 7, 6. You'd have a 9 factorial. Is that okay? Any others? So let me be very clear. On the written section of your test, you're going to have something like number 5, or, I guess number 5 for now. So make sure you can solve a factorial equation. I guess you all can. Cool. I hope. Or ask me another day. Yes? Did you try it? I would love to do it. Okay? By the way, 5b, I would have moved the factorial. I want the factorials to the same side so that I can expand and cancel some of them out. Here they are on the same side. Yay! What's bigger, Nathaniel? N plus 2 or n? I'm going to start to expand the top. This is going to be n plus 2 times, what's 1 less than n plus 2? N plus 1 times, what's 1 less than n plus 1? Is that what appears on the bottom? Okay, then instead of writing n, n minus 1, n minus 2, n minus 3, I can replace all of those with an n factorial, which conveniently is what I have on the bottom. That equals 12. I'll FOIL this out. You can remember FOIL from the good old days, back when math seemed easy, yes? N squared plus 3n plus 2 equals 12. What kind of an equation is this? How do I know? Make it equal to 0. Because I'm running out of room, I'm going to cheat. I would minus 12 from both sides, which would make this a minus 10. Yes? Does it factor? Yeah, it will. Numbers that multiply to negative 10 and add to positive 3. Can I have negative 5 letters? Can I have 2 letters? Yep. By the way, if I gave this to you on a multiple choice question, don't solve it. Just try the 4 numbers on your calculator, please. Because there will be, the answers probably would be 5, 2, negative 5, and negative 2, or something like that. if it's multiple choice, because this takes a while, please be clever enough to just plug in the answer. You guys are smart enough as test writers to have done that, yeah? Well, don't worry, we'll get there. Any others? Today is a continuation of last day. All we're going to ask today is, okay, what if the same letter appears more than once? For example, last day, I think we did the permutations of the word compute. And I said, how many letters are there? And you said, oh, there's 7. Or was it 7? Yeah, 7. And I said, are they all different? Yeah. Today we're going to ask very simply, what about the word Mississippi, which has multiple S's and multiple P's and multiple I's? What if the same thing appears more than once? So if you would be so kind as to get out your notes from last day and find lesson 3, this here one here. If you don't have your notes from last day, get in the habit of folding them in half and tucking them inside your workbook, and that way you only have to remember to bring one thing. I will loan you a copy for today to follow along with, but it's nicer if you have them. Here we go. The permutations of the 4 different letters A, B, E, and F above are, we actually typed them out. How many permutations are there? Well, I didn't need to write them out, although I can say, well, it's 4 times 6, there's 24. But really, it's how many different letters? The answer from last day was 4 factorial, which is 24. Write down both, because although 24 is the answer, I'm going to see if I can spot a pattern in the factorial notation. Okay. Then it says, what happens if 2 of the letters are the same? We're going to investigate this, and the way we're going to investigate this is, in this group of letters, which came from 4 different letters, we're going to make every F and E by just adding a line like that. Can you do that really quickly with your pencil or pen? Because now what we're saying is, what happens when you have 2 E's in every word? You did that? And here's what I notice. If instead of using A, B, E, F, I use A, B, E, E, both those groups are actually identical, aren't they? And both those groups are actually identical, aren't they? Both those groups are actually identical. So I don't actually have 24 different possibilities, because this one appears twice. I'll say, you know what, I'll just ignore it. This one appears twice, I'll ignore that one. This one appears twice, I'll ignore that one. You know how many different permutations there are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah? 12. Now here's my question. How does this number, this answer, compare with the original answer? Can you say instead of it's half, can you say in terms of divided by? Divided by what? How many of the same letter did we have? And what did we divide by? I wonder if that's the rule. So I'm going to write down right now thinking maybe it's 4 factorial divided by 2. Now it isn't quite. We're going to have to tweak this, but that's our starting point. What happens if 3 letters are the same? Now the way we're going to do this, Shannon, is we're going to take all of the E's and F's and make them B's, like that, so that we have A, B, B, B. Really quickly do that. Make all of the F's and E's into B's. Take about 30 seconds or so. Help yourself, Nicole. Is that okay? You done? And here's what I notice. The whole first row is A, B, 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 B. Or, well, A, B, B, B. And the whole second row is, in fact, you know what? All 6 of these groups are identical. Yeah? See it, Amanda? Which means really, don't count those twice. Do you know how many, if there's 3 letters the same, how many permutations there are? 4. Now here's my question. How does that compare to this 24? Steph. 24 divided by 4 is 4? I don't think so. 24 divided by... Strike 2. Please hit the next one out of the plate. Okay. Don't write this down. Sorry, write this down, but don't write the denominator down yet. I'm going to write that for now, but then I'm going to say it would be really nice if there was a 3 there. Because it would be very wonderful if I could say for 2 letters, put a 2 down there. For 3 letters, put a 3 down there. Is anybody really clever? Can you see how I can write 6 as a 3? And I'll give you a hint. Think about yesterday's lesson. Hey, Nicole, what? Is 3 times 2 times 1 6? Oh, and Steph, see this here? Is that still true? Is 2 factorial actually just 2 times 1? 2? Oh! Are you saying the rule isn't divide by the number of repetitions, it's divide by the number of repetitions factorial? Which actually is pretty clean. If you have the same letter appearing more than once, Holly, count how many times it appears, and it's the total number of letters factorial divided by how many repetitions factorial. That's not bad. It's not bad at all. Oh, and by the way, you could make the argument, if you wanted to make the rule generic, that this is actually 1 factorial, because every letter appears once. I'm not going to bother because that really looks ugly, but that's the rule. Turn the page. So it says, generalize the pattern from the investigation on the previous page to determine the number of permutations of how many letters grand total? 5 over how many repetitions? Go to your calculator. What's the answer? Or this one, the numbers are small enough you might be able to do in your head. It's 5 times 4 times 3 times 2 times 1 divided by 2 times 1. Oh, the 2's cancel. Oh. How do you type that in? Oh, let's review. Where was that factorial button? Itzel was away last day, so she's going, where the heck is it? So Itzel, clear, clear, clear. Type 5. Factorial is press your math button, which is just below the green alpha. And then all of the stuff that we'll be doing for the next month is under the probability menu, which is left arrow. Option number 4. Divided by. This is where, Holly, it's worth remembering a few basic factorials. For example, I know that 2 factorial is just 2, and it's much faster to type that than to go 2, math, left arrow, down now, option 4, enter. In fact, you know what I memorized? I know 2 factorial. What's 2 factorial? What's 3 factorial? Please go 3 times 2 times 1 in your head. And what's 4 factorial? 4 times 3 times... Sorry, no one else answer. Steph, what's 6 times 4? What's 4 factorial? 24. I have those ones here because those are the most common ones, because not many English words have more than 4 of the same letter. So you're going to see me often write factorial, but in my calculator I'll type 24. Or I'll write 3 factorial, I'll type 6. Anyways, 60, yes? B. What expression am I going to write here? How would I calculate this? What over what? Shannon. Now, here's what I'm going to do. Second function, enter. I'll leave the 5 factorial. Shannon, what was 3 factorial? Because it was 3 times 2 times 1. Hey, that's way faster to type. 20. Start using keyboard shortcuts. Otherwise, your fingers are going to start bleeding from the blisters of typing so much after a while. 20. What would this one be? Cassandra, what over what? Four factorials, 4 times 3 times 2. In fact, you know what? 5 factorial is 120. That's also one I have memorized because I'm lazy. 5. By the way, can you see that this had to be 5 just by looking at this? Because isn't it on the top 5 times 4 times 3 times 2 times 1, and on the bottom 4 times 3 times 2 times 1? And I would argue there I shouldn't even have gone to my calculator. I should have included in the 4, the 3, the 2, and the 1 are going to cancel. All it's going to be left on the top is a nickel. Right? Ah! What about here? Oh, what's going to be on the top? Carson. No, I got to be fussy. 5 factorial. What's going to be on the bottom? Carson, how many B's? How many C's? Yeah, that's the rule. Oh, Carson, what is 2 factorial? What is 2 factorial? What's the bottom really if I were to evaluate it? 4. Ooh, I'll just delete the 2. That's even quicker. 30. What do you think the expression, Amanda, would be for E once you're done sipping your coffee? Coffee or tea? Tea. Over. Yeah. A nice clean rule. We haven't really proved it, but it's working, so we'll trust it. Evaluate that, please. Now, by the way, if you are typing in factorials into your calculator and there's more than one in the denominator, physics kids, if there's more than one number, put it in brackets, right? But I think I would go 5 factorial divided by bracket, and I would probably go 6 times 2, or I might even be tempted to say, hey, that's a 12! Ryan, whatever, but 10, yes? Because, of course, you have your calculator out and are following along, yes? Right? Oh, it is there. I'm sorry. I saw something else. My bad. So here's the rule, the generalization. If you have n objects, that's how many ways to mix them up. Oh, but if A objects are alike of one kind, and B are alike of another kind, and C are alike of another kind, it's n factorial over A factorial, B factorial, C factorial, ... however many different letters repeat. So, determine the number of permutations of all the letters in each of the following words. Ogopogo. 1, 2, 3. Try this one on your own. I'll do it up here silently, and let's see if we get... And folks, you have to be able to evaluate the answer, so please make sure you can get an answer. Is it 105? Oh, by the way, little note on your graphing calculators. Look up for 1 second. If you actually go 7 factorial divided by, and you put a bracket there, and you go 4 factorial 2 factorial. Oh, it does work. On some calculators, you had to put a times sign between them because it didn't know what to do with a number after an exclamation point. Never mind, these ones it does work. I think it was the Casios where you had to put a times sign. Statistician. now we're at the stage where I'm really not going to try doing these in my head, although I will go 2 times 6 times 2 times 6. Oh, I forgot to divide. Duh. You get 3,326,400. We are well beyond being able to list these to check to see if we did it right. There's no way we're going to list Ryan 3 million permutations. Ain't going to happen. So I said at the beginning of this unit the theme was counting without counting. There we are. 3,326,400. Before you turn the page, I'd like you to do me a favor. At the bottom of the page here, I would like you to write your first name and your last name as it appeared on your birth certificate as one word. So mine is going to be this. Your first name and your last name as it appeared on your birth certificate as one word. Here's the question we're going to ask. Suppose you're doing a computer software program and the password that it's going to make up is going to be a permutation of the letters of your first and last name. I'd like you to find out who has, find out the permutations of your first and last name combined as one word, who has the most secure first and last name, who has the crappiest first and last name, and I didn't buy stickers for both if you want. So, turn the page. Okay. A true-false test has 7 questions. How many answer keys are possible if 3 answers are true and 4 answers are false? Say what? You know what? I'm going to write out one possibility. 3 trues, 4 falses. Hey, isn't that a word? How many letters long is this word, grand total? 7. How many T's are there? 3. How many F's are there? This is why I said to you the other day, we keep going back to words because it's very easy for me to change a question into a word question. This is going to be a 7-letter word with 3 T's and 4 F's. If I want to have 3 trues and 4 falses on my true-false test, how many different possible answer keys can I make? Evaluate this one, please. $35? And then for some reason, do you guys have a grid there or not? Why did the grid suddenly vanish over the years? Bear with me, let's go see if I can find it. We'll do pathway problems another day. We pause at the end of this. Can you turn, please? In your workbook, which I know you all have, to page 389. Page 389. We're going to go off on a bit of a tangent now. We're going to say, okay, what if they give me a permutation, but there is some kind of a restriction? Okay? This is where I'm going to fall back often on the fundamental counting principle, drawing a blank, and my Scrabble grab bag analogy. Number 1 says, how many different ways can all the letters of the word oranges be arranged if there are no further restrictions? All right, first of all, are there any repeating letters in the word oranges? No. How many letters are there grand total? So the shortcut was 7 factorial, or it was drawing 7 blanks and saying, how many do I have to pick for the first one? 7, now 6, now 5, now 4, 3, 2, 1, 7 factorial. First letter must be an N. Now I'm going to fall back on the fundamental counting principle. I'm going to say, okay, 1, 2, 3, 4, 5, 6, 7. The first letter has to be an N. How many ways do I have to pick this first letter? Now, how many letters are there to pick from? 6, then, oh, okay, now I'm going to stop and I'm going to use the shortcut. Instead of writing 6, 5, 4, 3, 2, 1, I'm going to go over here and I'm going to say, what can I do on my calculator? 6 factorial, which is what? Yeah, I mean, type it in. I think it's 720? Yeah. You'll start to see some of these numbers popping up all the time. You may memorize a few because you're naturally lazy. 720. Okay. C. This is the one I kind of like. The vowels must be together in the order O, A, and E. So here's what I'm going to visualize. I'm going to draw a little Scrabble grab bag here. There's an R, there's an N, there's a G, and there's an S. And then there's one weird tile. And on this weird tile, O, A, E. Because that's what it says. The vowels have to be together. How many tiles, Nathaniel, are there in this grab bag? Count carefully. 5. The answer to this is, even though there's 7 letters, there's 5 choices. Okay. Which is 120, I think, yeah? So here's how I can deal with weird ones. If they want some combination of letters sticking together, I'll think of it as being written on one single tile. Oh, what if they had instead said, at a part D right here, part C, but in any order. The same question as part C, except these don't have to be OAE. Ready? I would say this. Same question to begin with. How many different tiles are there? 5. And how many different ways can I mix up those 3 letters? How many different arrangements are there of those 3 letters? How many choices do I have for the first letter on this tile? 3, then 2, then. Right? Which is 120 times 6, 720 again? No, yeah? Yeah, 720? I've got it. The answer always ends with 20. No, that's just a fluke right now. So, in how many arrangements, by the way, this word here is another word for permutations. I'll use it on a test. It drives me crazy because I give kids a question on a test and I say, find the number of arrangements, and they think it's a combination, which we're doing later on. Permutation or arrangements. Are the vowels together? So what I'm going to visualize here is a B, an R, an N, an S, and then one tile that has A and I on it, but I won't write them down because I don't want to somehow suggest that's the correct order. I'm going to say, okay, how many tiles are there to pick from? How many tiles are there to pick from? 5. And how many choices to mix up the mystery tile? Because there's 2 letters on it. By the way, 2 factorial is just 2, but I'll write the factorial notation to remind myself we are doing a permutation here. Which is what? Sorry? 240? Example 3, A. The letters kitchen, are all the letters different in the word kitchen? Yeah, okay. The K, C, and the N must be together, but not necessarily in that order. Okay, let's draw my little picture here. So we have this weird tile. Oh, heck, I will put a K, C, N, but I'm going to remember that I can shuffle it around. And what else do I have? An I, a T, an H, and an E. Yeah, did I miss any? I, T, H, E, and... Oh, yeah, sure. How many tiles grand total? And how many ways to mix up the mystery tile, since it says that we can mix it up? 3 factorial. I know 5 factorial is 120. I know 3 factorial is 6. Is it 720 again? Yeah, we did that up here. Like I said, a lot of numbers start to repeat because you're factorialing factorials. Example 4. In how many ways can 3 girls and 4 boys be arranged in a row if no 2 people of the same gender can sit together? Oh, wait a minute. I didn't do B. I didn't leave enough room to do B. I'll just talk about how I would do B. I wouldn't. Well, I sort of would. As soon as they want me to do a not question, I find it easier to find how many where the vowels are together. What I would say is, how many different words, how many different arrangements can I form of those letters? 7 factorial? Then do this question in A, but instead say that I and E have to be side by side. If I subtract those, that's how many where the vowels are not. And if I lost you, don't freak out. Example 4. How many ways can 3 girls and 4 boys be arranged in a row if no 2 people of the same gender can sit together? You know what? I'm not sure. I'm going to go back to drawing a blank. And if I got 4 boys and 3 girls and I want to go every other gender, what must I start with, boy or girl? Think about it. How many choices do I have for the first boy? Skip. How many choices do I have for the next boy? Skip. How many choices do I have for the next boy? Skip. How many choices do I have for the next boy? How many choices do I have for the first girl? Then I could go 4 times 3 times 3 times 2 times 2 times 1, but it looks like this is 4 factorial, 3 factorial. I didn't see that going in, but I notice it after the fact now. That's why I said on the first lesson, Cassandra, whenever they give me a weird question, my fallback is the fundamental counting principle, drawing a blank, Scrabble grab bag, and then often I'll spot a factorial shortcut that'll get me there. What is 4 factorial, 3 factorial? It's not 7 factorial. What is 4 factorial, 3 factorial? Sorry? 144? Okay. Six actors and 8 actresses are available for a play with 4 male roles and 3 female roles. How many different cast lists are possible? Well, I guess we're going to pick from males. We're going to pick females. How many males are there grand total? 6. How many am I picking? 4. How did we do that? Okay, this was from a 6-letter word. Pick 4 of the letters. This was when we did this last day. 6P4. This was that 6 permutate 4. How many females are available? How many am I picking? What am I going to do with these 2 numbers? I'm going to give you a hint. 6 actors and 8 actresses. Or means add. You know what and means? Because you have that many choices for the first group and that many choices for the second group. It's the fundamental counting principle. Where was the NPR? Also in the same submenu, right? 6, math back, 2, 4, and 8, math back. You got 120,960 possibilities? Now, there's another way you could have done this. You could have said, falling back on the fundamental counting principle, I want to pick 4 boys, 4 males, 3 females. How many choices do I have for the first male? 6, then 5, then 4, then 3. How many choices for the first female? 8, then 7, then 6. If you multiply those out, you'll also get that. It's a permutation. Turn the page. Example 6 says, how many odd 5-digit numbers can be made with the following digits if no digits can be repeated? Okay. How long are the numbers? How many digits long? 5? You know what? I think I can draw 5 blanks. There might be a shortcut, but I can draw this out. 1, 2, 3, 4, 5. We want this to be an odd number, right? Okay. So that means this has to be odd. That's my restriction. That's my condition. I'll always do it first. How many choices do I have for that last digit there? 1, 2, 3, 4. Okay, I picked one of them. How many choices do I now have for my first digit? 6. Then. What is 6 times 5 times 4 times 3 times 4? 30 times 12 is 360 times 4 is 1,404, 14,440? Yeah. Okay. B. Again, they want odd numbers, 5 digits. So again, I'm going to, for 5 digits, Tyson, I'll just draw a blank. For like 12 digits, I might try and find a shortcut, but maybe even not. I might just still draw 12 blanks and fill them in. Oh, and this has to be odd. How many choices do I have for this last digit, Matthias? Let's see. Can end in a 3, or a 5, or a 7. Yes? For it to be an odd number. How many choices? Nice and loud. 3. Okay. I picked one of them. How many choices for the first digit? Careful, I don't think the answer is 6. Why 5 and not 6? What can't I start with? 0. Okay, I picked another digit that wasn't a 0. Now 0's back in play. Got 5 again. Then 4. Then 3. 25 times 4 is 100 times 900? Double check me. So that's looking at some continuation from the last lesson. What if we give you weird curveballs? Restrictions. Oh, repetitions. We've already talked about that, so let's skip this page and let's, on page 391, here's the rule that I gave you. Okay. Oh, heck. Vancouver, the big city close to us. How many permutations are there of this word? Oh, only one A, only one M, only one C, only one O. Okay. You get 181,440? Yeah. Mathematical I won't worry about since we're getting the hang of this. Poppies. got 3 P's in it, so it's got some repetition. So my guard is up, I'm a little more alert. How many different arrangements without restrictions? Okay. 1, 2, 3, 4, 5, 6. We're with us now? Okay. This is going to be 7 factorial over 3p. That's it. Uh, 840? Yeah. If each arrangement begins with a P. Okay. Now we're getting a little weird. I think now I'm going to start kind of falling back a little bit on the fundamental counting principle. I have to start with the letter P. How many choices do I have for that first letter P? Let's suppose it was that one. Now how long is my word? How many letters? How many P's are left? What's going to go right here between these two numbers? Multiply, because it's the fundamental counting principle. Let's try that again. I have to put a letter P here, but I don't cross it out. What I'm still saying is for the remainder of them, there's still 3 P's grand total. Why, Mr. Dueck? Because I'm not going to give you all the rest anyways. I'm not going to freak out about this. These are overkill. This I expect you to handle, not the weird conditional ones. And I think I'm even going to skip example 9. Instead, I'm going to say, what's the homework? Oh, what was the answer to this? 360 when you crunch this? Is this right? Okay. 1A, B, and C, those are fair game. Two is fair game. 3A and B. D and E. So skip C. Five is okay. 6 is okay. 8. A. 12. This is a word. 2 C's, 1 R, 1 G, 1 S, 3 A's. Isn't it? I can treat it that way. This is a word. 1 C, 2 B's, 2 E's, 1 A, 2 K's. 14. Okay. We'll pause there.